Okay, in chapter 8, we have three different kinds of tests we're going to run. We're going to do tests about a population proportion. We don't know. We're testing to see if a population proportion is true. So there's three requirements, three condition checks you want to do to know whether that's true. So let me come down here. So you got to have a simple random sample, of course. You always have a simple random sample. Otherwise, your data's crap and you can't really do much with it. You have to make sure that it's a binomial distribution, right? That you're, only two, yes, no answers. Probability stays the same from trial to trial, a fixed number of trials, and so on and so forth. And then, of course, you're going to meet these things because otherwise it might not be a normal distribution, right? Once you get that done, then you can run this test. So how do I recognize this? Well, if I come to, let me go to a version of the week 8 WebAssign. So this is I skipped all the earlier parts because that's the foundational stuff. What you were asking me was, how can I tell? So this corn problem, I don't see any standard deviations. I don't see any means. That's a flag to me that this is about proportions. I also know that the claim is that 15% of his corn has worms in it. And if we do that NP thing just to make sure, 15% of 120 is certainly bigger than 5 because 10% of it is bigger than is 12, right? So, and then 85%, 1 minus that, is also going to be bigger than 5. And it's the yes, no, yet does it have an earworm or no? And whether one group of, arguably, you could say maybe the test of independence, because if a field's got earworms in it, a lot of them have earworms in it. So that's a stretch, but so then that's the testing I'm going to do. So I know I know it's a one proportion z test, or a test about a proportion. Now, how do you run it? Well, there's enough other. I don't know if you were asking me that. There's enough other videos about that, and probably have posted about this. But that's what I do. That you run the condition checks. That makes sure you're going to do the right test. And then what do you do to actually do the calculation? I would, as I pointed out many times to your folks, I mean, please go use Rossman Chan. Don't do it by hand. I mean, your graphing calculator works. Your spreadsheet works. I don't know how to do it on a spreadsheet, and I could figure it out. But this Rossman Chanson, what you do is you just select one proportion because this is about proportions. You type in your n, extra n, calculate it, set your whatever H1 it is. Remember to write your claim, write your HO and H1 on paper. That way you have it. And then you can just use this and calculate it and get your answer. There's your test statistic. There's your p-value. Make your decision. Okay, so that's for that one about corn. Let's come back and take a look at another one now. So then this one, binge drinking. So again, let's see, I don't see any mean or standard deviation reported. So this must be about proportions, and then half. The claim is that half of all college students binge drink. So 50%, that's our P. 50% of 5.5 is bigger than 5 either way. So yeah, this is all set to go. Because this is a two-tailed test, you just got to go back to that Rossman Chance site. Where is it? And you're just going to make sure, type in 0.5, put in your X and your N, one proportion again, X and N, click on this until it says two-tailed, and then calculate it, and you got it. Okay. So let's come back and look at another one. Then this is about sleep. I see an average of 7 hours of sleep. Then I see a sample result with a mean and a standard deviation. So this is about means. This is a quantitative variable. It's not a proportion. If there's one sample, do we know the population standard deviation? That's the thing we got to ask ourselves. Well, we know the population average. We think we know the population average. That'd be HO mu equals 7, and then we're trying to test the claim that college students get less than 7 hours on average. So that would be HO would be mu equals 7. I don't have my board with me today, so I can't write on the screen. I mean, you don't want me to try to write with a mouse. Mu HO would be mu, that funny M, that funny U equals 7, and then HA would be, or H1 would be mu is less than 7, because that's the claim. So then, because this is a one sample, and I know it's a t-test. Well, I know it's a t-test because I see a t there, but also because I didn't know the population standard deviation, it's got to be a t-test. And then we got sample size bigger than 50. Let me point you out the requirements for that while I'm thinking about it. So here, let me zoom down and get there. Still on the proportions. So now, see here, hypothesis test about a mean, population standard deviations not known. Okay, that's so this is in section 3, and they tell you the formula. What are the conditions? Do they tell? Where do they talk to us about the requirements? Where's Dr. Stevens talk about? Here we go. We have to have a random sample, of course, and you have to have a sample size bigger than 30, or that parent population has to be, you have to know it's normally distributed. And a problem, they'll tell you. We know this about sleep, so, but because we had a sample size of 50, we're good to go. Okay, so that's how I know. I don't know the population standard deviation, and the sample meets these requirements. Okay. So this is about means. It's about one sample, one mean, right? So what we're going to do is go to Ross and Chance, do the drop down for one mean, type in, set up your HO and HO. In this case, it would be 7 and less than 7. And then we got to type in our X and N. I don't know what, I'm going to make this up, 6.2. I mean, I know I could flip back and see what it is, but, and then what, 0.7, like I said, I'm making this up. Calculate it. And there's the p-value. Oh, wow, look at that test. It's significantly different. P-value 0. Now I'm wondering to see what actually is the values. 6.83 and a standard deviation of 0.4. So 6.83, pretty close to 7. And what is it, 0.4? Let's recalculate that and see what it looks like. Still, that sample average is way below 3 standard deviations, right? And so it's, I mean, it's eight standard deviations, t-square of 8, it's p-value 0. Data supports the claim that college students, we're going to reject HO. Data supports the claim that college students get on average less sleep than the normal, the rest of us. Well, I don't get 7 hours of sleep. I do know that, but it's okay. I digress. So there's that one. Salmon, raw data. We know that the weights of Chinook salmon are normally distributed. We only have 15, though. We don't know anything about the population standard deviation. We can calculate a mean. They tell us that the mean weight. So I know this is about means. It's one sample. They don't give us the data, so we gotta find that. I posted a video on how to do that in the week 8 discussion forum, so I won't do this here. But so that's the same test, a one sample t-test. We know the parent population is normally distributed, so it's okay that we've got less than 15 salmon. Okay, so again, that's at 8.3 section. I think it's 8.3, right? Yeah, 8.3. Okay, let's come back and take a look at the rest of that problem, the rest of these problems. Now salmon, see here what's different here, as I know the population standard deviation. So this is a one sample z-test. Now there are calculators you can do to find to do this. We can, how do I want to get this to you? I'll try drawing. I don't have my mouse, of course. So because this is a z-test, we're going to say HO, well, let's find in the claim. Test the claim the mean weight is greater than 24. So that's going to be a right tail test. So HO, we're going to say mu equals 24. Notice I put the mu in there. People forget the parameter. And H1, mu is greater than 24, and that's the claim. That's the claim. Now we're going to do the test statistic. So what we'll do is do a z-score, and we'll do the sample mean was what? Sample was 26 pounds, so we'll do 26 minus the 24, and then we're going to do the standard deviation, and population standard deviation is 4.1 pounds. So 4.1 divided by the square root of the sample size, which is 26. So we crunch that number, we write it in, we go look it up in the Z table, or it's a right tail test. So it might be easier to do that with the Rossmann-Chance, with not Rossmann-Chance, but with David Lane. Let's see, let me do this calculation. 4.1, let's see, 4.1 divided by square root of 26. Oh, Dan, I messed up. 26. I'm getting 0.08. All right, let me try to write this. That becomes, the denominator becomes 0.805, something like that. I don't know if I got it all. And the top is 2. So 2 divided by that number, and I'm just going to let my calculator carry that. So I'm getting a Z-score at 2.48. 2.49, I guess. So then we're going to put that into Rossmann-Chance and not Rossmann-Chance, but into David Lane, or you can look that up in a table. So if you're going to look this up on the normal curve table, right, you're gonna look this number up on the table. That's going to give you the left area, because this is a right tail test. We're going to take it away from 1. Or you can just go use here. Maybe I should open up David Lane just to look at that to see. Here, David. That's how you spell. Lane, pop up. Let's see if that pops up right there. So I'm on the standard normal curve because I made a Z-score. So I want, and it's a right tail test, so I want to go above 2.48 or 2.49. I'll go with 9 since it's just here. So there's the p-value. Okay, small p-value. It's a 1% level of significance. I think reject HL. Okay, so that's that situation where we know the population standard deviation, and that is this next section in chapter 8, where it talks about one mean population standard deviations known. He does say it's optional, but all the textbooks have us do it. And if you're looking the essential objectives for the course, we have to do it. It's not that bad. And if you want to go find a calculator to do it, you can. Graphing calculator will do it, but it's really pretty easy to calculate. It's easy to find the p-value, easy to find the critical value of Z. Just so you remember, on this normal curve table in the book, see at the bottom here, these are Z-scores. These are the critical values. Those are the cutoffs. So if you're not going to do the p-value method, you can use that and see if your test statistic is out in the rejection region, right? And then you probably have seen that. So, okay, so are there any other questions in that web assignment that we want to hit to make sure yep, that's the last one. Okay, so important to do those condition checks, especially with the next chapter, chapter 6. And please use those for chapter 9. You can do everything with that Rossmann-Chance calculator. You don't have to do anything else. It'll do it for you. Just going to select the 2 means or 2 proportions. Okay, or the 1 if it's a match pairs too, and that's just a 1 mean. Okay, I digress. Let me stop this video.